Very good morning to all of you. This is lecture number 8 in which we will see PIN diode and its application, it's working. Before that, I will choose one pen. Okay. Then I will choose color for that one. Until I will prefer black color. Okay. So let's start with the lecture. So it's good morning everybody. So it's a heavy rain outside. So don't go outside your home as Corona is also waiting for you and there is huge rainfall outside. Heavy rainfall outside your home. Better way, stay in your home itself. So this is lecture number 8 in which I will discuss about a PIN diode. It's working. It's some application of PIN diode and all that. So what exactly I mean by PIN diode and all that we will cover in this particular lecture. So before directly starting with the lecture, if you are not subscribed my channel, please subscribe the channel. So in which we are getting the latest update of every video which I have uploaded on my YouTube channel. So if you want to browse to every videos of my whichever video I have uploaded on my YouTube channel, so please go through playlist and you will get the micro engineering subjects, all videos from very start video of the syllabus discussion or then ADC you will got all the lectures, and if you want to see the discrete time signal processing, then you will also welcome for this one. Okay, if you any doubt, please give me your doubt, your ask me a doubt in your comment section so that I can solve your doubts. Yeah, so exactly mean by pin diode. Pin diode is nothing but the in the last lecture we have discussed that in intrinsic semiconductor, like semiconductors are normally silicon. Okay, I can go for silicon, either I can go for germanium, GE, okay, or GS I can go for. But if it is in the intrinsic mode, that is nothing but pure semiconductor. So it is we can say that it is we can't use that one. Okay, we can't do practical use. It is not a practical use. But if the only application of pin diode in the intrinsic mode is nothing but diode or PN junction in the intrinsic form is nothing but the pin diode only application. Keep in mind, if somebody is asking about you that give me the application where intrinsic material is used, so you can directly without any hesitation you have to give the answer that pin diode is the only application in which what we are doing, we are using the intrinsic layer. Okay, so p type and n type we have discussed in this one. So what is that? If in this pure silicon or germanium, either silicon, germanium, any intrinsic semiconductor material, if you are adding boron, indium, okay, and gallium, BiG, these are the pentavalent impurities. We can, why we are calling as impurity, because we are adding to the pure semiconductor, that's why it is called as impurity. So boron, indium and gallium, which is having how much? 3 valence electrons, so it is called a trivalent. Okay, and if you are using antimony, arsenic and phosphorus, if you are adding antimony, arsenic and phosphorus, so the resultant whatever the material is called as n type material. Okay, what you can say, and its valence is how much? 5 valence electrons. Okay, 5 electrons in the last orbit, so that is called as n type material. And if you are using boron, indium and gallium, then whatever the resultant material is called as what is called as n type, sorry, p type. So I will rub the things. I will take eraser and I will erase this part. Yeah, I will take then pen again once again. Just okay. So we are using, if you are in the intrinsic, in the middle one, okay, middle one, if you are adding boron, indium and gallium, so it is resultant device is nothing but what resultant nothing but what? P type material. Okay, I will show like this one. And if we are adding AAP, so that is nothing but the resultant material is nothing but N type material. Okay, this is clear to you. Okay, this is all we have discussed in the last lecture. We have discussed about the energy band gap and all that things. I think Aniket has given the answer. Correct answer is that correct answer is, I think I have asked you the question that which is if the uh, carrier concentration concern. So ascending order, you have to mention the three: gallium, GAS, then germanium and silicon itself. So Aniket has given the correct answer. So if you are not still you are not an answer, then please go through the answer in comment box. You have to give me the answer of that one. Okay. So this is the construction of this PIN diode. Okay. So what exactly in this construction? So normally think about this. Our subject name is microengineering. Okay. Microengineering. So if I want to design a satellite, okay, if I design the satellite that will which will operate at the micro frequency, okay, what micro frequency, in that one, if I want to use one device that is nothing but the diode, okay, diode itself. So normal, if you are using the BC547, normal we are using this diode BC547. Yeah. In the practicals you must use this diode or BC545 also or 557. This is the ENPN, PNP diode, PNP transistor. So these are the normal diode we are saying. But if we are increasing the frequency, if we are increasing the frequency, then which kind of diode we have to use? So that is the best example is nothing but our PN diode. Okay, PIN diode we can say that. So what exactly it means contains? So yeah, the top layer, that is the metal contact, top metal contact, and at the bottom also metal contacts are there. Why we are using metal contact? Because we are taking a lead from this one. We are taking lead from this side and we are taking lead from this side. So this is the symbol of this one. So in the top metal contact, so the second layer, this is the red kind of the P plus contact region over there. Here is the P plus contact region and here is the P plus P diffusion layer. Okay, so what kind of diffusion layer is nothing but what, suppose this is the intrinsic layer, larger depletion layer is there. Okay, then it is nothing but the n-type metal over here and n plus contact region over here. This is the n plus contact region here and this is the bottom metal contacts are there. So I will again drop this whole part again, and I will explain to you in detail this thing. Yeah, I will take pen. Okay, so what exactly it means that I want to tell you. Suppose this is again, I will ask you one question, what it exactly this means. What exactly it means, suppose I am placing two metal contacts over here, metal plates I can say that, and in between that if I am using an insulator, or I can say that dielectric metal. Okay, so what will happen in this case, what exactly it means, write down in comment box. I'm watching over comments what exactly devices means. The short device is what, I'm expecting your answers. Okay, so this is nothing but a simple capacitor. A simple capacitor. This is nothing but I am what I can say. I am having two metal contacts in between dielectric metal. So keep in mind, intrinsic region or intrinsic material is there. This is extremely pure form. We can't use this for conduction itself. Keep in mind what trying to say. Intrinsic material, because in the intrinsic, if this is the one layer, that is nothing but the valence layer. Okay, valence band is there. So we know that holes and electron are generated in the pair. Okay, one electron is generated and one hole is generated. So number of electron in the conduction band is equal to number of holes in the valence band. Okay, so number of holes and number of electrons are the same one. Okay, so number of holes and number of electrons are the same one. That's why what will happen, the current conduction will not happen. So intrinsic layer we can't use practically. Okay, can't use practically, so it is act as what, insulator, or we can say that it act as a dielectric material. Okay, we can use it as a dielectric material. So what will happen? Suppose this is a capacitor. Okay, capacitor itself. So we know that capacitor is equal to what? Or capacitor is directly proportional to what exactly? That is nothing but the A by D. Okay, and if I am saying C is equal to some constant over here, some constant, I mean that A by D. Okay, so if area of this plate, this area A is nothing but area of the plate, and D is nothing but the distance between these two plates. Okay, this area of the plate, and this is nothing but the distance in between these two plates. Okay, so what will happen if the area is more? The area is more, then what will happen? Area is more, then capacitor will increasing. Capacitor will increasing, and if distance between these two plates is less one, the capacitor will be more. Capacitor will be more. So now keep in mind what will happen if I am connecting this diode in forward bias like this one. Okay, I think this is the forward bias. So P type over here and this N type. So what will happen here if the P junction is there? So just a minute, I will drop this portion once again. Okay, I will take pain again once again. Just wait a minute. Okay, I will connect in reverse bias. That is negative over here and positive over here. Then here you will know that here holes are there. That is nothing but the positively charged. We can say that. Okay, positively, and here you will find electrons over there. Electrons are over there. Then what will happen? Suppose this is the primary drawing I have drawn over here. Then if I'm putting in the reverse bias, then the holes will attracted toward this negative terminal. Yeah, and the electron will get attracted toward the positive terminal. Okay, so what will happen? This electron and this will, whatever the junction, whatever this width of this one will get increasing. So what will happen? Suppose this is the primary position of this one. Then in the next portion, what will happen? The distance between these two plates will be increasing. Distance between the two plates will increasing. So we know that if distance between the two plates is increasing, then what will happen? Capacitor will cause to be decreasing because it is in the inversely proportional format. So distance is increasing, so capacitor will decreasing. So again we know that relation between capacitor and my frequency. So that is nothing but the F is equal to what? 1 divided by 2 pi 2 pi Fc. Okay, this is Fc. Yeah, this is capacitor C. So again this is in the inversely proportional. Then if my capacitor is more one, so frequency is less one. And if my capacitor is less one, so frequency is more one. So if I'm relating my frequency, this frequency with directly with the distance, so that is nothing but if my distance is more one, the frequency is also more one. Because if my distance is less, here is distance is more one, so capacitor will, what you can say, what is the value of capacitor value is again if less one, and if is this is less one, so frequency is more one. Okay, because it is inversely proportional. So directly we can say that if distance is more one, then uh, it is having higher frequency, and if the distance is low, then it is lower frequency itself. So by changing the potential across this, we can operate at a different frequency. So this device will act as a switch in between two frequency. How I will give you the answer for this one. Just I want to rub this portion. I will drop this portion. Just a minute. Okay. So suppose if I want to use this PIN diode across the two SIM cards. Now I want to give you the real-time situation with you. Okay, if I'm having two SIM cards with me, suppose this is my SIM card one and this is SIM card number two. Okay, and if I'm calling, if somebody, this is my SIM cards on my mobile. If somebody is calling on my single this SIM card, then what will happen? If I'm talking with somebody on this SIM card, first SIM card, this is SIM card number one, and this is SIM card number two. But suppose if person calling on my SIM number two, then what will happen? I'm not getting a waiting call from this one because my conversation is going on SIM number one. If somebody is calling on the SIM number two, then what will happen? It shows that it's out of coverage area and all that thing. Instead of it should give the waiting call for me. Suppose this is an important call, then I can take the call itself. So if you want to switch in between these two, so I must such kind of device that is nothing but a pin diode in between two, though it will handle multiple frequencies as simultaneous. So if both SIM cards are there, if I'm talking on the first SIM card and I'm getting a call on second SIM card, so likewise I'm getting a waiting call for this one because of changing in the frequency of simultaneously for this one. So this is a simple application of PN diode. Okay, so we'll stop over here. In the next lecture, I will explain you in the detailed working of this pin diode to you. Okay, till that, take care of yourself. Thank you very much for attending my lecture. Thank you.